In the differentiation, maxima and minima means if one function is there in the two dimension, y equal to f of x, it is x-axis, it is y-axis. In case it is a function f of x, this is the starting point and the ending point here, and then what is called the extreme point or maxima and minimum point. The maximum point means this is the maximum point in the y. So for the respective value of x, the function attains some maximum value at the point. The point is x comma y. This is the maximum point, and then you have to find what is the maximum value at the point x comma y. And then you can see here, even if it is start here, but maybe the curve may be come like that. Then here you can see it is the minimum point. This cutting point is the minimum point. So this is the definition for the maximum and minimum. And then how to find that maximum and minimum? See the definition for minimum and maximum. Let x not be a number in the domain D of the function f of x, and the f of x naught is the absolute maximum value of f of x and c. What is called the absolute maximum value? Absolute means mod value. To take that only positive value, that is called absolute value. F of x on D. D means domain. You know that set theory, in the set theory, domain and range is there. Domain is x, and then range is f of x. It is domain D. Domain D, and it is called the range. The procedure, what is the procedure to find the absolute extremum value? Extrema means already I told now, extrema means maximum or minimum value. Maximum or minimum value is called extremum value. In the closed interval a comma b. What is called the closed interval? We will discuss in the interval topic, but here just I will tell you what is called the closed interval, what is called a open interval. Closed interval means in case the interval 0, 1 is there, 0, 1 is there. If it includes that both the points on the edges, that is called the closed interval. That means a less than or equal to x, less than or equal to b. If less than or equal to is that includes both the points, that is called the closed interval. Otherwise, in case if it is an a less than x less than b, it is called open interval. It is called a open interval because see that less than is there. That meaning is that last value is not included here. It is include the last values a and b. If it is a, if it is b, then it is called a closed interval. If it is less than is there, it is not contained that both the extremum points, that is called a open interval. So that's why both the extremum points contains that, then only we can find that maxima and the minima. So and then one more thing, it is possible only for the closed interval. What is the procedure to find the maxima and minima? First step is some f of x is given. Some f of x is given. You have to find the critical number of f of x in a comma b. What is called the critical number? Critical number means if f of x equal to f of x is given, then you can find that df by dx. So have to find the df by dx and then substituting equal to 0. Finding the first derivative of that given y equal to f of x, then equating to 0. If you are solving this equation, you will get the point of x comma y. You will get the point of x comma y or x, the point of x. Then that equation, sorry, that point is called the critical number. And then you have to find that second derivative d square f by dx square. Find the d square f by dx square, then substitute that whatever value you get in the second order differential equation. If it is maximum and minimum, based on this we can write which is the maximum, which is the minimum. Okay, now listen. How to find that? One small example is there for this. Find the absolute maximum and the absolute minimum value for the function f of x equal to 2x cube plus 3x square minus 12x on minus 3 comma 2. How to find that? See, differentiating the given function is f dash of x. Given that f of x, f dash of x is 6x square plus 6x minus 12. Okay, if you are solving that, you are getting that f dash of x equal to 0. So you will get that minus 2 comma 1, x equal to minus 2 comma 1. Minus 2 comma 1 is belongs to minus 3 comma 2. It belongs to minus 3 comma 2. Therefore, the critical numbers are minus 2 comma 1. Both the numbers are minus 2 comma 1. Evaluating f of x at the point x equal to minus 3 comma 2 and at the critical numbers x equal to minus 2 comma 1. So what is f of minus 3 here? 9. What is mean by f of minus 3? Here f of x is there and then you have to substitute x equal to minus 3 in the equation, then that value is called f of minus 3. If you are substituting that minus 3 in this equation, you are getting that value 9. And then extreme, one more extreme point is 2. If you are substituting 2 here, you will get 4. And then what is the value of minus 2? F of minus 2 is 20. F of minus 2 is 20. And then f of 1 is minus 7. So from these values, the absolute maximum is 20. The absolute minimum is minus 7. So when it occurs, when x equal to minus 2, it attains that maximum value. When x equal to 1, it attains the minimum value. Don't judge that when x is negative, then it is the minimum. When x is the positive, then it is the maximum. Don't judge like that, because that function may be like that sometimes. When x is maximum, the function may be like that. The function may be like that. So when x equal to minus 2, see that when x equal to, approximately I am writing x equal to minus 2, then it attains the maximum value of y. When x equal to plus 1, when x equal to plus 1, and then it attains that f of x attains the minimum value. After that, what happens is, in case if it is the minimum value, afterwards that function may be go like that. Here the function may go like that. So if it is a continuous function, then when x equal to minus 2, it attains that maximum value. When x equal to plus 1, it attains the minimum value. That is one method. Other method is, you have to find that f double dash of x. You have to find that f double dash of x. What is f double dash of x? What f double dash of x is 12x plus 6. F double dash of x is 12x plus 6. Then if you are substituting, these are the values now, x equal to minus 2 comma 1. If you are substituting x equal to minus 2 here, what do you get? If x equal to minus 2 means minus 24 plus 6, minus 24 plus 6, that is equal to minus 18. Listen, if f of x equal to 0 and f double dash of x is less than 0, then f of x has maximum. F of x has maximum at the point. In case f of x is f dash of x equal to 0 and the f double dash of x is greater than 0. F double dash of x is greater than 0, then f of x has minimum. Then f of x has minimum. Okay, we can check it then. If you substituting that x equal to plus 1 here, f double dash of x is there. If you are substituting x equal to plus 1 here, what do you get? 12 plus 6, 18. F double dash of x at the point of 1 is 18. And then it is greater than 0. It is a point. So f of x has minimum value. You can check it here. So 20 is the maximum at the point x equal to minus 2. Already told na, f of x has maximum value when f double dash of x is less than 0. And then it has a minimum value at x equal to plus 1. So what are the rules for maxima and minima? No need to write, just listen. F of x has maximum, f of x equal to, f dash of x equal to 0, f dash of x equal to 0, and then f double dash of x is less than 0, then f of x has maximum value. If f dash of x equal to 0 and f double dash of x is greater than 0, then f of x has minimum value. F of x has minimum value. Please keep it in mind. In case if it is a trigonometric function, what is the maximum value? 1, minimum value minus 1. Maximum value plus 1, minimum value minus 1 if it is a trigonometric function. Trigonometric means sine and cos, not for others. Because cosecant, secant may be that infinity value is possible. But for sine and cos, maximum value plus 1, minimum value minus 1. So what is the next one here? Next example is find the absolute extrema. Extrema means maxima or minima. Extrema means either maximum or minimum. Find the absolute extrema of the function f of x equal to 3 cos x on the closed interval 0, 2 pi. See, always cos x is 0, lies in between the 0 to 2 pi only, because 0 to what is pi? Pi is 180 degree. Pi is 180 degree, and then 2 pi means 360 degree. Cos and sine, both of them lies between 0 to 2 pi only. Otherwise, what is the cos curve? Cos curve is like that. If it is 1 here, and then it starts from here, so it goes like that up to 1. What is the minimum here? Minimum is minus 1. Maximum is plus 1. Once again, it is 2 pi value. Here, x equal to 2 pi. Afterwards, it goes on like that. It moves on like that. What is this point? This point is 4 pi. Okay. So here, how to find that the maximum and minimum value for the given function f of x equal to 3 cos x? Differentiating the given function f dash of x. F dash of x is minus 3 sin x. That is, keep it 3, and then differentiation of cos x is minus sin x, so minus 3 sin x. See that f dash of x equal to 0, sin x equal to 0. Sin x equal to 0 when the sin is 0. When the sin is 0. Theta equal to 0. Theta equal to pi by 2 is what? When theta equal to pi by 2, then what is the value of sin?
1, sir.
1. Then once again when it is 0,
180.
180. 180 means
Pi.
pi. So 0, pi, 2 pi, 3 pi, etc. But here given the interval is 0 to 2 pi only. 0 to 2 pi only. Therefore, x equal to 0, x equal to pi, when, sorry, sin x equal to 0, when x equal to pi belongs to 0 to 2 pi. So, when x equal to pi, when x equal to pi, what is f of x value? What are the endpoints? 0 and 2 pi. 0 and 2 pi. And the critical number is x equal to pi. Critical number is x equal to pi. F of 0 equal to 3, because when you are substituting that x equal to pi here, x equal to pi here, cos pi f of 0 3, f of 2 pi 3, sorry, yeah, f of 0 3, f of 2 pi 3, f of pi is minus 3. That means what is f of x here? F of x is 3 cos x. If you are substituting x equal to 0 here, then you will get that 3 cos 0, 3, and then if you are substituting pi here, cos pi value is minus 1. So minus 1 means minus 3. F of pi is minus 3. So from these values, the absolute maximum is 3, which occurs at x equal to 0, 2 pi, and the absolute minimum is minus 3, that occurs equal to x equal to pi. And then one more thing, how to calculate that maximum and minimum value? As usual method is, if f of x equal to, sorry, f dash of x equal to 0, you will get that 0, pi, 2 pi. What is f double dash of x here? As per procedure, what is f double dash of x here? Minus 3 cos x. Minus 3 cos x. So when you substituting that 0 here, you will get that minus 3. If you are substituting pi, that means if you are substituting 0 under 2 pi, you will get minus 3. That means f double dash of x is less than 0 or 0 under 2 pi, and then f of x as maximum. F of x as maximum value. Is it not? When you are substituting that, when you are substituting that, when you are substituting that x equal to plus 5 here, then f double dash of x is plus 3, because cos pi value is minus 1. Cos pi value is minus 1. Already minus 3 is there. Minus 3 and minus 1 plus 1. And then f double dash of x is greater than 0 at the point pi. At the point pi. So instead of substituting all the values in f of 0, you can follow this method. Find that f of x equal to 0, find that f dash of x and then substituting that is equal to 0, equating to 0, and then find f double dash of x, then substitute the critical value in that f double dash of x, In case f double dash of x is less than 0, f of x has maximum value. In case f double dash of x is greater than 0, then f of x has minimum value. Please keep it in mind. Next problem is for what value of x the function y equal to x square minus 4x will have the maximum or minimum value. This is very direct problem. Direct problem means for what value of x the function y equal to x square minus 4x. That means you have to find only the critical points. What are the critical points? No need to find that what is the maximum, what is the minimum. So here at what point or for what value of x the function y equal to x square minus 4x will have the maximum or minimum value. See the solution. Given y equal to x square minus 4x, find the dy by dx is 2x minus 4, and then dy by dx equal to 0, that is 2x minus 4 equal to 0, but if you are finding that x equal to 2 here, x equal to 2 here. So at x equal to 2, the function will have the minimum value or maximum value. But particularly we can say the function has a maximum value or minimum value. How can you find that? In case if you are finding the d square y by dx square, d square y by dx square, that is equal to 2. It is greater than 0. It is greater than 0. Therefore, when the d square by dx square is greater than 0, then d square by dx square is greater than 0, then y as minimum or maximum? Minimum value or maximum value?
Minimum value.
Minimum value. Y as minimum value. And then one more thing, what is the minimum value here? What is the minimum value here? Just substituting that y equal to x equal to 2 na. So 2 means 4 minus 8. So minus 4 is the minimum value. There is no maximum value for this. Maximum value is there, but we are not able to find for the particular problem. Next one is velocity and the acceleration. Velocity and the acceleration. You know that distance is s. In case distance is denoted by s, be the function of time t. Be the function of time t. Velocity is the rate of change of displacement. Velocity is the rate of change of displacement. That means rate of change of displacement is s. Then with respect to rate of change means differentiation. So that means derivative with respect to what? With respect to time t. Rate of change of displacement with respect to time t. With respect to time t. So how can we write that? Velocity v equal to ds by dt. Already we have studied this thing. Just you have to recap this point. Acceleration is the rate of change of velocity. Acceleration is the rate of change of velocity. So rate of change of displacement is velocity. Rate of change of velocity is acceleration. So that is, it is denoted by a. That acceleration is very useful in finding that dynamics problem. All the dynamics problems are either heat conduction. What is the application, main application of this velocity and acceleration is that heat conduction, wavelength, signals and systems, aerodynamics. So there is a lot of applications are there. Whenever the function is changing with respect to time t, usually in the real world, everything is based on, most of the things based on time t. Sometimes some events didn't change with respect to time t. For example, if you are in the probability, if you are tossing a coin, if you are tossing a coin with respect to time t, there is no change in this. When you are tossing the coin at 6 o'clock, it is same. But in the night, whenever you have to toss, you will get the same answer. But if you see the temperature of the day, if you see the temperature of the day, it is keep on changing. It is keep on changing. Morning, very less temperatures is there. Afternoon, it will be very high. In the evening, so once again, it will be go very less. So some events are with respect to changing with respect to time t, then the process or the application is known as the velocity and acceleration. See here, what is called the initial velocity? It is the important notes are there. First note is at time t equal to 0, we get the initial velocity. Then the second point is when the particle comes to rest, the initial velocity v equal to 0. When the particle comes to rest, that means what? When the particle comes to rest means, listen, in case the particle is here, if I push the particle, so it's moving, and then after some time t, it will come to the rest. That means it stops its displacement. When a particle stops displacement, then keep on changing is different. Keep on, the velocity is same. That is different. Keep on changing, the velocity is different. Our standard velocity is different. Velocity come to rest is different. Okay. At time t equal to 0, we get the initial velocity. How to write the initial velocity? ds by dt at t equal to 0. What is meant by ds by dt? ds by dt means rate of change of displacement. Rate of change of displacement at t equal to 0. Otherwise, ds by dt also can be written as velocity at time t equal to 0. That is called the initial velocity. When the particle comes at the rest after time some time t, then the velocity v equal to 0. Third one is when the acceleration is 0, velocity is uniform. When the acceleration is 0, velocity is uniform. For example, if the satellite, if you launch one satellite, in the beginning, velocity, what is the velocity in the beginning? 0. Velocity of because there is no displacement at a time t equal to 0. You didn't count. Then you start the count. Then the rocket launching starts. It goes very high speed at the initial. Afterwards, some height. After them, it reaches some height. Then it will be stable. It will be stable and then goes in the same speed. Goes in the around the earth in the same speed. It is moving, but the velocity is that uniform. The velocity is the uniform. The velocity is not changed with respect to time t. At that time, the acceleration is 0. At that time, the acceleration is 0. Now, we will discuss few problems in this. If s equal to 5t cube minus 3t square plus 10t, find the velocity and the acceleration after time t seconds. Very simple. If you are differentiating one time, that is velocity, that is ds by dt. So if you are differentiating that 5t square minus 6t plus 10. And then if you are differentiating one more time, 2 times, then that is, it is also known as d square s by dt square. That is also known as d square s by dt square. So it is a common problem actually. After t seconds means, listen, here not mentioned any t. In case if they are mentioned any t, you have to substitute here in the place of t. What is the value? See here, you can see the second example. In the second example, the distance s is traveled by the particle in time t seconds is given by s equal to 4t cube minus 5t plus 6. Find the velocity at the end of 10 seconds. Find the velocity at the end of 10 seconds. That is s equal to 4t cube minus 5t plus 6, v equal to ds by dt. So v means velocity here. That is range of rate of change of displacement is, if you are differentiating is this one, 4 into 3, 12, 12t square minus 5. So if you are substituting t equal to 10, here given that t seconds is there. So t equal to 10 here, you will get that v equal to 12 into t square, 10 square, that means 100 minus 5. So 1200 minus 5 is 1195 meter per second. And then here also, you see that there is no unit for distance is given, but you can write the unit for the second. That means per second you can put, even if you are writing that meter or centimeter, whatever it may be, that is independent of the scale, because your distance scale is not given there. So as your wish, you can write the distance scale, but time scale is given, that is seconds. So we can write that 1195. Either you can write that meter or centimeter, whatever it may be. That is depends on you. This is the first problem, very simple problem, finding the velocity and the acceleration. And second problem is finding the velocity at the time, at a particular time. See the third problem. Third problem is the distance time formula of moving particle is given by s equal to 7t cube minus 5t square plus 12t minus 3. Find the initial acceleration. Initial acceleration means, acceleration is d square y by dx, d square s by dt square. Initial acceleration means you have to substitute v equal to 0. So here t equal to 0. T equal to 0 means s is distance, displacement. And then finding that v is that velocity ds by dt. We are finding the ds by dt. 21t square minus 10t plus 12. Then find the acceleration. Acceleration is dv by dt. Acceleration is dv by dt. 42t minus 10. Now we have to substitute the t equal to 0 here. If you substituting t equal to 0 here, acceleration is minus 10 unit per second. So here simply they are writing that unit now. Similarly, we can write that here unit. You can write instead of minute, you can write unit per second here. Here given that it is second, but here given that it is the second square, because in the displacement already per second is there, and then in its acceleration one more per second will come. So unit per second square you have to write. This is the third problem. Fourth problem is if the distance is meters. So here mentioned that meters. Now, if the distance is meters traveled by a body in t seconds is given by s equal to 5t square minus 20t plus 12. Find at what time the velocity vanishes. Velocity vanishes means that is equal to 0. So you have to find the t value. So you have to put that v equal to 0. Then we have to find the t value. See that s is given 5t square minus 20t plus 12, and then velocity is ds by dt 10t minus 20. But the velocity vanishes means v equal to 0. V equal to 0. Substitute v equal to 0 here. 10t minus 20. So t equal to 2 seconds. So we have to read the problem carefully. Whether they are asking the velocity or acceleration or initial velocity, initial acceleration, or what is the time t for velocity vanishes like that. These are all the very simple MCQ questions. The next question is find the initial velocity of the body whose distance time relation is s equal to 8 cos 2t plus 4 sin t. Is based on the trigonometric function. So s equal to 8 cos 2t plus 4 sin t. What is dv here? Sorry, v here. That means ds by dt minus 16 sin 2t plus 4 cos t. What is the initial velocity here? Initial velocity means substituting t equal to 0. Substituting t equal to 0, initial velocity. If you substituting t equal to 0, sin 0 value means vanishes. But cos 0 value is 1. Therefore, 0 plus 4 equal to 4. See. Take 5 minutes break, then you can start the class. So, if they are not those who are latecomers, then join in Google Classroom. Now, so already I explained how to join in the Google Classroom. So, go to the Google Classroom. There are many, only 13 students have joined here. So once again you try to join the chat box. Once again I put that the link for this. Please click the link and then you can join. Now it is 18 students are joined. Only 18 students are getting that register number. 12 students didn't get that. What is date today? Date is 7. Give your attendance, Kavya.
Present, sir.
Kavita. Shivashelli.
Present, sir.
Archana. She's here. Silestri.
Present, sir.
Ritika.
Present, sir.
Paul Samuel.
Sir.
Madhubala.
Present, sir.
Ishantini.
Savita present. Sir.
Present, sir.
ಯಾರೇ
Savita present, sir.
ಕವಿತಾ ಪ್ರೆಸೆಂಟಾ ಸರಿ
Yes, sir.
Sir, Nishantini present, sir.
ನಿಶಾಂತಿನಿ ಪ್ರೆಸೆಂಟಾ
Yes, sir.
ವರ್ಷ
Present, sir.
ಶಿಫಾರೋಕ್ಲಿನ್
Present,
Sir,
sir.
Archana.
அர்ச்சனா என்ன நம்பர் இருப்பான் அர்ச்சனா 4
Sir, all Samuel present, sir.
All sound well present. Vinod Sam,
Present, sir.
Vigneshwar,
Sir,
Pradibha,
sir, please am correct.
Pradibha,
Present, sir.
சொல்லுப்பா யாரு?
Sir, number 5 present, sir. Please am.
சரி. Supriya, Naveen Kumar,
Present, sir.
Ashwin,
Present, sir.
Rashmi Ranjan,
Present, sir.
next problem this. The distance, the time formula of a moving particle is given by s equal to a e power t plus b e power minus t. Show that the acceleration is always equal to distance traveled. So what is the distance here? S equal to a e power t b e power minus t. You find the velocity next. Velocity means differentiate with respect to t. That means a e power t, e power t differentiation is e power t only. But e power minus t equal to minus e power minus. Differentiation of e power minus t equal to minus of e power minus. So you will get that a e power t minus b e power minus t. That is velocity. And then acceleration. Acceleration means once again you have to differentiate the velocity. If you are differentiating velocity a e power t, already minus is there. If you are differentiating e power minus t, once again minus will come. So this minus minus will plus a e power t plus b e power minus t. You can see that what is given distance a e power t plus b e power minus t. We compare with the acceleration, both are same. Therefore, that is equal to, we can write that is equal to f. So acceleration a equal to f. See that the next problem, the distance s meters per time t seconds traveled by a particle is given by s equal to t cube minus 9t square plus 24t minus 18. Find the velocity when the acceleration is 0. Find the acceleration when the velocity is 0. So first we have to find the velocity and the acceleration. It is the distance formula s. Then find the velocity. That means one time differentiate. We are getting the 3t square minus 18t plus 24. And then second time differentiation is acceleration. So acceleration velocity differentiation is acceleration. Differentiate one more time 60 minus 18. But what is the question here? Find the velocity when the acceleration is 0. Find the acceleration when the velocity equal to 0. Now we can see that how to find that. Find the velocity acceleration is 0. Substituting acceleration equal to 0 here. If you are substituting acceleration equal to 0, t equal to 3 seconds. T equal to 3 seconds. Substituting t equal to 3 in velocity. Substituting t equal to 3 in velocity. That means 27 minus 54 plus 24. That means minus 3 units per second. Similarly, substituting v equal to 0 because we have to find the acceleration when the velocity is 0. Substituting v equal to 0. It is a quadratic equation. See that 3t square minus 18t. 3t square minus 18t plus 24 equal to 0. That means t equal to 2, t equal to 4. Either t equal to 2 or t equal to 4. When t equal to 2 seconds, acceleration is minus 6 meter per second square. At t equal to 4 seconds, acceleration is 6 meter per second square. So when that acceleration equal to 0, they are getting only one velocity value, but that velocity equal to 0. Since it is a quadratic equation, they are getting the two results for that acceleration value. Okay. Next problem is, that is enough.